All right, AP statistics. Let's do some free response examples. I'm fairly sure at least this one come from a previous AP exam. I think the next one as well, but I can't really verify that. So this one we're looking at. First, we have to decide: are we talking about the sampling distribution of the sample mean, or the sampling distribution of the sample proportion? I see right here, sample mean, and I think that we're talking about the sampling distribution of the sample mean. So let's go ahead and describe that. If we're going to describe the sampling distribution of the sample mean, I want to describe the shape, the center, and the spread. Not necessarily in that order. The center is what I'm going to start with, right? That mu sub x bar is the same thing as our mean of our population. It tells me that the population of songs has a mean length of 3.9 minutes. Rock and roll song. You have rock and roll songs. They're good. American like rock and roll and Levi jeans. We are Russian. We don't like. We only watch people fight. Okay. I probably just defended Russian. Right. So anyway. So we got the mean. So we got center. How about spread? The standard deviation of our sampling distribution of our sample mean is going to be equal to our population standard deviation divided by the square root of our sample size. So in this case, we know that the standard deviation of a rock and roll songs is 1.1, and we're taking a sample of 40 songs. So I'll go ahead and put that in my handy dandy calculator. You Americans use calculator. All right. Let's describe the shape of the distribution. For the sampling distribution of a sample mean, if the sample size is greater than 30, or the sample comes from a population that is known to be normally distributed, then we can say that the shape is approximately normal. In this particular case, n is greater than 30 because n is 40. Therefore, the sampling distribution is approximately normal. So the one thing that's left off is that before I calculate this, or if I calculate it, I also have to address the 10% rule, right? So for this, I have to say that we can assume there are more than 400 songs in the population. And now we're good. All right, so let's answer a probability problem now. If the program manager schedules, and I don't need to read it for you, you guys all are probably very good at reading. So what's going on here? We need the probability of the total amount of time needed to play 40 randomly selected rock and roll songs exceeds the available airtime. And so the little trick, the little thing that kind of you need to figure out is because we have a mean length of one song, right? But how long does one song need to be to not exceed that amount of time? So what we need is we need for one song then could not exceed uh 160 divided by 40, right? 40 songs in 160 minutes, so it cannot exceed 4 minutes on average, right? Our average song length cannot exceed 4 minutes. All right, so all right. So what are we looking for? We're looking for the what is the probability that it exceeds? So what's the probability that basically our average song length is greater than 4, right? That's going to be the probability that we exceed uh, that that duration is actually equal to 4. Okay. Okay. All right. If we look at this distribution, you know, I love drawing these. It's my favorite. 3.9 is here. Our standard deviation is around 0.174. So oh no, it's actually much closer in, isn't it? 4. And we're looking for the probability that matches with this, or that is represented by that shaded region. Okay. Keep in mind that I am going to have to do a normal calculation in order to find that area, and it's okay because I already did this, right? I've already done it previously in the problem. I have stated that the sampling distribution is approximately normal, so I can go ahead and perform some normal calculations. All right, so I'm going to use my normal CDF. That is going to be, my lower bound will be 4. My upper bound will be some large number. It should be infinity, but, you know, calculators don't understand that. And, or at least ours don't. And then lower bound, upper bound mean is 3.9. Standard deviation is, what was it? 0.174. All right, we're going to get some answer for that. It's going to match this answer. I'm going to get a calculator. Oh, I have it open. So here it is. I'm going to go ahead and just, it's not like confused this, I have the calculator page open, so moving that. So we're going to go menu, probability, distribution. We're going to look at the normal CDF. I said our lower bound was 4. Upper bound is going to be a big old number. And our mean was 3.9, and the standard deviation of, was it 0.174? Yeah. And we get approximately 0.283. Oh. All right, so in this probability problem, I have included all three things necessary: the conditions, the kind of stuff that a grader will be looking for, right? I have checked the 10% rule. I have stated that the distribution is approximately normal before I perform normal calculation. I have included a probability statement. I have provided my calculator command, and as a bonus, a picture of the shaded region that represents that probability. You could get extra and you could express this as a z-score as well. I saw some people do that. I love it. I'm not going to do it right now. So let's move on to the next question. Just straight up looking at a probability right here, I am going to have to describe the distribution of this. In this case, it is the sampling distribution of a sample proportion. I have to do it in order to do the problem, really. So your friend offered to play a game with you. He's flipping a coin. But he's going to say, hey, you can flip it 50 times, right? To see if it's a fair coin. Right? If it's a fair coin, if you flip it 50 times, should have around half of them come up heads. So you flip it 50 times and you get 30 heads. Right? So they should have about 25 heads. I think I said something different just a little bit. 30 exceeds that, right? About half of them come up heads. So it looks like what we have now is that our sample proportion is equal to 30 out of out of 50, or come on, felt the need to check that in the calculator, but some days I'm just not feeling sure, confident. But there we go. All right, so what am I looking for? Well, first of all, we got P, which is the same thing as mu sub P hat, is 0.5, right? In addition, I would like to know what is the standard deviation of my sampling distribution of my sample proportion. We have a formula for that. It's in your AP formula sheet, but I'm going to write it down. Anywho, so that is going to be our standard deviation, 0.5 times 0.5, right? That's 1 minus 0.5 divided by, there are 50 trials in our sample. So we got the square root of 0.5 times 0.5 divided by 50 is approximately 0.071. Only if we can assume that there are more than 500 flips in the population of flips. I know it's weird. That's weird, right? But we have to assume there are infinite flips in the universe. I mean, really, realistically, assume there are more than 500 flips in the population. Of flips. All right, now we're good to go with that. I have almost described the entire sampling distribution. I know I'm going to have to do some sort of normal calculation, right? Why don't we just check for normality right now? And in order to do that, I need to show that n times p is greater than 10. And I need to show that n times 1 minus p is greater than or equal to 10. 50 times 0.6. Swear that's a 0. Is that greater than or equal to 10? Indeed, it is 30. That one's good to go. How about 50 times, well, all right, sorry, wrong number. We need 0.5. All right. So number 25. And this one indeed is also 25. So we're good. So we may assume the distribution is approximately normal. Now that we've done all this stuff, we can actually start answering the question. And I think that's the thing that people struggle with, is that you got so much to do before you can actually get an answer. And maybe it's a point of frustration. What's the probability that we were to get 30 or more heads given 50 flips, right? So let's look at that. So in other words, what's the probability that the proportion of flips is 0.6 or greater, right? So in other words, we're looking for the probability that p hat is greater than or equal to 0.6. We'll get some approximate answer for that. I love drawing these, so I'm going to draw one. And I recommend on the AP exam that you draw this. It shows that you understand what you're doing in another context. So that's 0.5. Looking at 0.6, we're looking for the area of that shaded region. In order to find the area of that short shaded region, I am going to use normal, CDF. My lower bound is 0.6. My upper bound is 0.5. My upper bound is infinity. My mean is 0.5. My standard deviation is 0.071. Let's put that in our calculator. Oh, I am just going to copy this down so I don't have to go through all that. And I can put 0.6 is my lower bound. My mean is 0.5. Standard deviation was 0.071. Good grief. That probability is extremely low, fairly low, lower than 10%. If it was lower than 5%, I would say there's something wrong with that coin, right? A probability of 0.07, I'm still going to be very suspicious. Very suspicious. The probability of flipping a normal coin and getting it to come up heads 30 out of 50 times is very unlikely. It's extremely unlikely. 0.079. Yeah. Don't fail me now. So,
No. Doing the segregation or
no insult is risk. Is risk. No insult is risk.
That does happen.
There is evidence. That the coin is not fair. Because in proportion of 0.6 is unlikely. And there we go. Examples. You're welcome. Have a beautiful day. And if you're not having a beautiful day, I hope someone smiles at you and makes it beautiful. You know the best way to get a smile? Smile at somebody.